Good afternoon. My name is Miss Bartlett, and I am an Algebra 2 teacher at Kennesaw Mountain. Maybe I'll be working with you in the future, but today we are going to review some factoring. Quadratics. The first thing we're going to work on is the greatest common factor. Okay, so we'll look at a couple of examples. So when you're looking for the greatest common factor, you're going to check the coefficients or numbers and the variables. And you're going to see what they have in common. Sorry, there we go. So 2 and 8. What can 2 and 8 be divided by? Well, I can divide 2 by 2 and 1. And I can divide 8 by 8, 2, 4, and 1. So the greatest common factor that they have in common is a 2. So we'll divide the common factor to the front. And now we'll check the variable. I have x squared here, but I have no x's here. So that means they don't have any in common. So the only thing that we can divide out, the greatest common factor, is 2. So since we're dividing, 2 divided by 2 is 1 x squared minus 4 divided by, my brain was working too fast. 8 divided by 2 is 4. So this would be your answer. Now, you can always check your work by distributing. So in case you would want to just double check that you've done this correctly, you could quickly say, okay, 2 times x squared is 2x squared, and 2 times negative 4 is negative 8. Which was our original problem. So yes, we got it correct. Yay! All right, let's do a couple more. Greatest common factor. So I tend to look at the numbers. This doesn't have a number in front, but we know there's a 1 there, and this has a 3. The only thing I can divide 1 by is 1. So we wouldn't divide by a greatest common factor of 1. We do not have a common factor for our coefficients, but I do see that I have 2 x's here and 1 here. So I can take 1 from here and 1 from here, and that is their common factor. I can take that 1x to the front of a set of parentheses. That'll leave me with 1x minus 3. Because we're dividing out that x, you had 2, and we took one of them away, leaving me with 1x minus 3. And again, you could always check your work. Sorry, that parenthesis is like super far away. I'm going to edit that for a second. And that would be my answer. And again, you can almost sort of visually check to make sure you've done this correctly by distributing. X times x is x squared. X times negative 3 is negative 3x. So we have checked our work. All right, number 3. Right, in this next example, I'm looking at the numbers. So what can I divide 5 and 25 by? What common factor? They're both divisible by 5. So that would be the greatest common factor. But also for the ends, I have 2 ends here and 1 here. So you're always looking, it's always going to be the smallest exponent amount. I'm going to circle both of those because I was talking. It's always going to be the smallest exponent amount. So for your variable, you always take the smallest exponent amount. So we decided we would divide by 5 and that we were going to take that 1 in as well. 5 divided by 5 is 1. N squared, when I take an n away, leaves me with 1n plus 25 divided by 5 is 5, and we took that n out into the front of the parentheses. So to check your work, we're going to say 5n times n, that's 5n squared. 5n times 5 is 25n. So I feel good about that. All right, so that's greatest common factor. Next, we're going to look at trinomials. With a is 1. All right, so usually, I'll go back for a second. Usually your greatest common factor, you only have 2 terms. 1, 2, 1, 2, 1, 2. Sometimes you could have a greatest common factor living in a trinomial, but it'll only be a common factor when it is 2 terms. We won't be able to do the next process for 2 terms yet. All right, trinomials. So we're looking at p squared minus 13p plus 40. So this back number we're going to look for what multiplies to 40. So two numbers that multiply to 40 and that add or combine to make negative 13. So what multiplies to 40 and combines to negative 13. So this is where your factor sheet comes in handy, in case you don't have all of those facts memorized. You would look for 40 on the factor sheet. So 1 and 40 would make 41 or 39 if I subtracted. 2 and 20 would make 22 or 18. 4 and 10 would make 14 or 6. 5 and 8 would make 13 or 3 if I added or subtracted. So because I get a 13 out of 5 and 8, I will use 5 and 8. But I also need to be aware of the signs. 40 is positive, so that tells me that 5 and 8 are going to have the same sign, either both positive or both negative. But since this is a negative 13, when I add them together, that tells me that they're both negative. So I'm going to set them in the parentheses, p minus 5 times p minus 8. All right, we'll do that again. So we look for what multiplies to the last number that goes in the top of my x. And when I combine or add them, they're going to give me negative 3. So I'll consult my factor sheet. I'll look at 70. So 1 and 70, and that doesn't make a 3. That doesn't make a 3. That doesn't make a 3. 7 and 10. 10 minus 7 is positive 3, or 7 minus 10 is negative 3. Let's see what kind of 3 we have. We have a negative 3. So 7 times 10 is 70. But to make this negative 3, we're going to put a negative sign on the 10, so that 7 minus 10 is that negative 3 we're looking for. So I'm going to put the negative here as well, make that negative 70. X plus 7, x minus 10. All right, the next type of problem you've studied are trinomials. With a greater than 1. All right, so we're also going to be checking for a greatest common factor in these. So I'm going to check out. I've got 5, negative 22, and 8. So 5 is odd, so I can't divide all of these by 2. 22 cannot be divided by 5, and 8 cannot be divided by 5. So there is no GCF. So we can check that off our list. Now what we will do is multiply. So we can't just find factors of 8 that add to negative 22. There won't be factors of 8 that add to 22. So you'll kind of be stuck there. So there's another step in this process, and that's because we put a number in front of the x squared. In the last problems, there was no number in front of the x squared or p squared term, and that's what we mean by a is 1, because there is no number in the front. But when there is a number in the front, here's what you need to do. We're going to take 5 and multiply it to 8. 5 times 8 is 40. And now we're sort of going back to that same process we were working on. We want two numbers that multiply to 40, but add or combine to that middle number, negative 22. So I'm going to check out my factor sheet. I need two numbers that multiply to 40 and give me a 22. Looks like 2 and 20 is the winning combination. But I do have to keep in mind my sign. So positive 40 means they're the same sign, but since this is negative 22, they're both going to be minus. They're both negative. All right, so here's where this process gets tricky. We're going to have to keep 5x squared and keep plus 8. And we're going to rewrite negative 22x using negative 2x let's do negative 20x minus 2x. I like to put the bigger number first. Because it'll just help me see what needs to happen in the next step. So I'm going to put minus 20x minus 2x. All right, so I'm going to split those down the middle with a plus sign. And I'm going to check each side for a common factor. Because now, if I look at 5x squared and negative 20x, 5 and 20 can be divided by 5. X squared and x, they have one x in common, so I'm also going to divide out an x. So that common factor comes to the front. 5 divided by 5 is 1. X squared divided by x leaves me with 1x. Negative 20 divided by 5 is negative 4. And x divided by x will be gone. Now on this next side, I want to end up with an x minus 4 in the parentheses after I've divided out that common factor. Anytime that you have a negative in front of this divide, you're also going to bring the negative with the common factor. So 2 and 8 can be divided by 2, but I'm also going to divide by a negative. So always bring the sign with that number. If it's positive, leave it positive. If it's negative, bring the negative with it. So negative 2 divided by negative 2 is 1x. Positive 8 divided by negative 2 is negative 4. These parentheses right here, these must match exactly. X minus 4 matches x minus 4. So we're ready to get to our answer. I'm going to take one of the x minus 4s. So we take one of the match. And for the other one, we're going to take those greatest common factors. So I've got 5x, and I wouldn't put plus negative 2. I'm just going to put minus 2. So these were the GCFs that we found. All right, I'm going to do that for you guys one more time. So again, we just check for a GCF across the board first. I'll show you one problem with a greatest common factor in the trinomial in just a second. But and it really doesn't take a lot, you just eyeball it. I've got a 2, a 13, and a 20. So 2 and 20, I could divide both of those by 2, but I can't divide 13 by 2. So there is no common factor in this trinomial. I also will not be able to find factors of 20 that add to 13. So that's another, that's like a red flag, I guess, to tell me there's an extra step. So again, because there's a number in front of x squared, I'm going to multiply 2 times 20 is 40. We want factors of 40 that add to 13. We're going to use 5 and 8. We keep the first number the same. We keep the last number the same. And we rewrite the middle. We're going to rewrite 13a using, I'll put the bigger number first, so AA plus 5a I split it down the middle with a plus sign, and we're going to divide out the common factor. So I divide 2 and 8 are divisible by 2. I can also divide out an a here. There will always be a variable in common on this left side. I have 1 a plus 8 divided by 2 is 4. So I should see a matching a plus 4 on this side after I've divided out the common factor. 5 and 20 are divisible by 5. 1a plus 4. We take the ones that match and we write it once. We take those common factors to a plus 5, and we put them in another one. I'm going to do one more problem. With a GCF and a trinomial. Like this. So we check for GCF first. So I have a 2, -20, and 18. All of those numbers are even. So it looks like they have a common factor of 2 that I'll divide out first. So I have 1x squared minus 10x plus 9. So once I factor out that common factor, I am looking at this leftover trinomial, and I'm going to factor it. So I'll find factors of 9 that add to -10. And I don't need to use this 2 to multiply to the 9. It is not part of what I'm doing right now. I kind of ignore it. I don't have to multiply anything to the 9 because I don't have a number in front of x squared. 9 is 1 times 9, but to make that -10, they're both going to be negative. So this 2 is still part of my answer. It comes in the front. This was our GCF. So you still want to have it. But I'm also going to have parentheses x minus 1 and parentheses x minus 9. So that would be my final answer. All right, thanks guys. I hope this has been helpful.